So I'm first going to discuss a bit about CQRS and event sourcing so that it's not that you have a bit of an idea what our view of it is, and then I'm going to start with the coding session. But so why is it interesting to follow this stuff? So over at Exxon, we believe in, if you're going to do microservices in your application, that you do that through an evolutionary microservice architecture approach. So let me give you an example of that. So let's take the stance you've got an application in mind which you want to create. It's going to change the world. It's going to be awesome. And as it's going to change the world, you need to be able to scale it because a lot of people are going to use it, right? So you start off with an application, and you follow the route of going to your microservice approach immediately. Well, we're not. It could work out doing that way, but we believe that will eventually end you up in Death Valley because going that approach means you're going to add a lot of infrastructure, a lot of complexity from the start. So you're not focusing on business value from the get-go. So that could mean that if you start off your application with microservices and you don't have business value fast enough, that your business thinks, well, this is not good. We wanted this stuff right now. We don't want you to be focusing on the microservices bit. So maybe they'll cancel a product. So we believe that's not the approach to take. So instead, we believe that you should follow the structure of just building a monolith, but a well-structured monolith. So separate all your components, put them in nice separate modules, and that's how you begin, so that you can focus on business value first. And whilst you're doing that, eventually you might find out that the blue bit is eating up a lot of processing power. And as you've modeled it correctly, you can pull it out and put it in its own microservice quite easily. And that's an approach you can follow whilst you're going on and scaling up. So this is what we believe, but how do you do this, right? And we think that CQRS and event sourcing help you with doing this. So that gives me a bridge to CQRS. So CQRS stands for the Command Query Responsibility Segregation. So I think the abbreviation already explains a bit what it is. It's separating the command side in your application from the query side in your application, putting it apart. So if you have this schematic, you can see that we have a client and it's talking to a thing, but those are two different clouds, two different things. And it does send commands to a bit to express the intent it wants to perform an action in the application. And the other side, the queries, is the intent, the request for data, the need for data. So that puts it to give it a more texture. You have a command model and a projections or a query model whilst doing this. So to focus on the command model is tailored to performing the actions it gets. So it receives messages only to do stuff. It doesn't return anything. So that's why we only have a single entry in it. It might send an OK back or a not OK, but it doesn't give you the result of performing that command. Also important to note here is that the command side is thus the point where you make the decisions whether it's valid to approach stuff, to do something. So that means that the only state it will need is the state it requires to make that decision. So there might be more state in your application, more stuff you have, but you don't need that stuff to make your decision, so you forget about that in your command model. The query model, on the other hand, is tailored to the needs of the application or the UI, which wants data. So you're setting up your views, your projections, as they are required by users. So you could call it denormalizing your data or setting up a table per view. So this is nice and all, but they're still somewhat part of the same application, right? So you need to synchronize the state between those two. And you could do that synchronization by having stored procedures or a shared data source. But what we think is nicer is to do that through an event-driven architecture, so through event sourcing. So this is where events come into play. What an event typically does in such a setup is a command is issued by a client, a UI, comes into the command model. The command model decides whether it's valid to perform that action, and if that's the case, it will publish an event through the system. And that event will be the sourcing bit for the command model, so that's where you update your command model, and the query model. Okay, cool, CQRS. That gives me a bridge to event sourcing, because we were talking about events, right? So what is event sourcing? Event sourcing, you could explain that by that rather than storing the application state as one thing, you're storing the state as deltas, as changes which are happening in your application. And from those deltas, you can hydrate back your application state at a certain point in time. So I think a nice example of this is Git. Because Git, you have commits, which are the events of your setup. And all the commits together make up the eventual state of your project. Cool. To give a bit more concrete example, let's put state storage and event sourcing next to each other. So in this case, we have a very simple order. with an ID, and there's an item in it, a deluxe chair, and we can see that the status is that the shipment has been returned. Okay, nice, but in event sourcing, that would probably look a bit like this. So there is an event notifying that the order has been created, that an item has been added, but also that one has been removed, or that all the status changes have happened. So, all right, from this you can already grab a couple of pros and cons to this approach. So this is my list here. The first one is that you have less information loss when doing this through event sourcing. What I mean by that is, if we go back to this slide, you see that we have 2 chairs added and 1 has been removed. That's stuff you're missing from the state storage bit. You don't have that there. You only have that when you're doing event sourcing. And you can do something with that state afterwards, so it's valuable to have that. Another one, the second one, so a reliable audit log. You can already see from this slide that you see all the changes, all the logs you have, all the things that have happened in your application. So that's, and we all know that it's a very important requirement nowadays to have a reliable audit log. And lastly, it gives you a certain performance increase. And the reason for that is that you're only going to do appends to the event store. You're only going to add stuff. You're not going to update those events. It just happens. You cannot change things in the past. You're going to remove stuff from the past. So it's just adding. And additionally, a delta is typically smaller than a complete application state to store. So storing a delta is probably faster than storing your complete state. It's not fair to discuss pros without discussing cons. So I've put a small list of cons up there as well. One thing you have to think about is that events have to be readable forever. So let's say you have got your application running for a year or 2, and you've got several order created events. But next to the ID, we already also want to add a name to that event. So we do that. We adjust our order created event to have a name in it. But we also have our old events in the database. So we need a way to adjust our old events to the new format, because we want to tell everybody about the new format rather than the old one. So you need to think about that. Another one, if you want to do a very rigorous rewrite of your event model, so all the events being your event model, that is probably going to take you a lot of work, because it's the basis of your application. All your command models and your query models are based on that event model. So pushing that underneath, that's a lot of work. So it's typically just a one-run tool only, but you need to think about that when you're doing stuff like that. And the last one I'm discussing here is that the sourcing of a query model or a command model could take a very long time, depending on the size of the events, the number of events you have. So let's say you've got millions of events which together make up your command model. That means you need to read all of them and then get your state back. Luckily, that's quite easily solved by doing snapshotting, which I won't go into. But all right, for my pros and cons. So what does this stuff have to do with Axon Framework? So first off, the Axon Framework is a Java framework. It's open source under the Apache 2 license. And what it does is it provides you the required building blocks to set up your application with CQRS and DDD, so domain-driven design and event-driven architecture in mind. Those building blocks are the event bus and the command bus, because you need a way to send those commands to your system, to the other components. And the same holds for your events. It gives you an event store and all the nice things you need for that. Secondly, it gives you a lot of annotation processing. So that means if you add a component in your setup where you want to listen to events, you can just add an annotation to the function where you want to listen to that event. So you don't have to bother about any Axon-specific plumbing there. You just add the annotation and that's it, and then it works. So by doing this, so if you want to set up your application with CQRS, DDD, and EDA in mind, you can by doing Axon, you can focus on doing the business functionality first, because all the plumbing is fixed for you. You don't have to worry about that. And that's what I can show you guys through a live coding session. So, yay, I'm going to code. I always love this bit, just being real practical and stuff. So there's a certain setup in my coding session. I'm first going to start off with the core API. The core API being the commands and events going to the system. Secondly, I'm going to start with the first cloud in the CQRS setup, so the command model. And of course, I'm going to end with a query model. But the application is nothing with a certain domain to code. And what better domain to take on a conference than a conference? So I'm going to code a very simple application where we can create conferences and add talks. That's it. Cool. That's it for this part. Let me open up IntelliJ for you guys. So I've set up a very simple Spring Boot application. And is this readable from the back, people? Yeah? Cool. So I've set up a very simple Spring Boot application. I'm going into the specifics because there have been many Spring talks on this conference. So this is my simple property setup. I've set up a Postgres database in this case, and I'm going to show you guys the POM. I've got a Spring Boot starter for data JPA, for web, because I'm going to make it a web application. And here's our Axon Spring Boot starter. So similarly to all the other Spring Boot starters, this automatically will wire all the required components for you from Axon. Postgres, we got in there, testing. And you can also see that I'm going to do a little bit of Kotlin. And I'm going to do Kotlin because it gives me a very concise way to write my commands and my queries, because the annotation is a lot shorter than it is in Java. So awesome, that's nice. So like I said, I'm going to start off with the core API here. So I'm going to add a separate package for that, because we're going to make it a well-structured monolith, right? So we're going to name that core API to keep it simple. We're going to add a Kotlin file, and we're going to call this conference API. So very simple. We can add several classes in this one Kotlin file. So I'm first going to create a class for the first command, the creating of a conference. So we name this a create conference command. So this is the constructor bit. I'm going to add immutable values to that. A conference is nothing with an identifier in it, so we add an ID there. And I've never heard of a conference without a name, so we add a name. I'm going to add one specific bit here. I'm going to add data to this bit. So what data means in Kotlin is that it will automatically create an equals, a hash code, and a toString for you. And it has a couple of other nice things I'll come to in a bit. But this makes it so that I've got a very simple, concise, immutable object, whilst in Java this would be probably quite some lines. So this saves me some time. The second command we're going to add is the addition of talks, because a conference without talks is nothing. And we're going to add another conference. I'm missing the class here, that's why it's not understanding it. Cool. Data. Yes. Vol conference ID. Auto create. Vol and a talk always has a title. And there's always somebody talking about a talk, so there's a speaker in there. Cool, so we got our commands. We're going to do a very similar thing to our events, so we're going to add an event which is telling that a command has happened. So a create conference command is handled by our command model, and then it's propagated through the system that it has happened. So a conference created event with the same fields as the command. So conference name in there. I'm going to do the same thing for talk edit events, vol conference ID, vol talk title, and the speaker. So this is our core API, and that's it. That's where we keep it at for now. So let's open it up to show that a bit. And we're gonna, so this is the point where we introduce the command model of our application. So the part which will handle our actions and make the decisions whether it's worthwhile. So as we're doing a well-structured one, we're gonna make a different package, which we could extract later on if we'd want to. And we're gonna add a little domain-driven design bit here. So I'm gonna make this an aggregate annotated class. So I'm shortly going to explain what an aggregate is. So an aggregate is a group of entities which together act as a single unit in regard to data changes. And there's always one entity in that set, which is the external reference. So the identifying bit within that aggregate, that's called the aggregate group. So I think a nice example of an aggregate is a car. So a car consists of windows, of wheels, of a steering wheel, of the wipers, the window wipers. Those are the entities in such a setup. And there's always one identifying bit on a car. You could identify a car by its door if it has a dent or a certain scratch on it, but you typically do that through the vehicle license, right? The license plate. So cool. Going back to Axon, so this is the first Axon annotation we're going to add, and this makes it so that Axon will search for all these annotations and know that it needs to introduce an aggregate factory and an aggregate repository for our conference aggregate out of the box. So we're going to add a default constructor in there because that's required by Axon, and we're going to add another constructor for our create conference command. Create conference command, like so. Cool. And we want to notify Axon that this is a command handling function. So this is another annotation I'm going to add to the mix, add command handler. So Axon will automatically look in all its components for all message handling functions. And this is a message handling function because it's going to handle command messages. And it will extract this function as a runnable and store it. And once a command, a create conference command comes in, it will call that runnable and do this stuff. So, all right. So we handle this command, and we want to publish an event based on this. So the way to publish an event in Axon is by calling the aggregate lifecycle.apply function. This is a static function you can only use from aggregates. And we're going to publish our create conference event. And we're going to fill that with the fields from our command. Awesome. So let's kill that one. So, all right, we've got a simple command handler, but we need to be able to identify this aggregate. So we need to have the conference ID as state within our aggregate. So this is the third bit of event sourcing we're going to add to this class. So we're going to do a public void on conference created event. And we're going to add another message handling annotation. So the event sourcing handler. And this is similar to the add command handler, but just for events in this sense. So Axon will automatically see this function. It will do that through reflection, retrieve a runnable from it, and call that one once a create conference command event is being published. But this will only handle the events which are published from this aggregate, not from other aggregates or other systems. It will only use its internal events. All right. And we want to extract the conference ID, like I said. So we're going to make that a field. Conference ID. We're going to get idea, create that field, and a string. And we need to notify Axon that this is the identifying field in this class by using the aggregate identifier annotation here. So this is our first command and event handling bit in here. And we're going to add the second command handler, so the add talk command. And this is not going to create our conference, so this is just a regular void. And the void here means that I'm not going to return anything, which we intended to. The command model is just to handle an action. It's not going to return the result of performing that action. So an add talk command, awesome. Going to make this an add command handler. Going to copy this bit, kill that guy. Cool. And we're going to apply the talk edit event. Going to pull the conference ID from its state, because that's now state in our aggregate. And the rest we're going to get from the command. Cool, like so. So nice, we got a second command handler. But we're not really showing the decision-making bit in this aggregate, because we're not really making decisions. We're getting a command, we're just publishing an event based on that. So let's take the stance that in a conference, we don't want two similar talks, right? We don't want somebody else to talk about the same thing. That's not worthwhile. So we're going to check whether the talk already exists for that conference. So to start that off, we need a list of those talks. So we need another event sourcing handler for that. But this time for the talk edit event, like so. Another add event sourcing handler. And we're going to fill a list of talks with talk titles, like so. I'm going to let idea do this bit again. Oops, list string, like so. Yes, awesome. And we're going to instantiate this list not in a constructor, but in the event sourcing handler, which is instantiating that conference. So the conference created event is the one which will trigger the event sourcing bit of this command model, of this aggregate. So this is where you do the instantiating of lists, in my view. So we're going to make this a new array list. Awesome. So we got that list, and we want to check that that guy exists on handling this command. So we're going to make this a field. If talks.contains talk title, we are going to throw an exception because we don't want this to happen ever. I'm going to call this a duplicate talk exception. And we don't have that class. This is a bit I'm going to add to our core API. So I'm going back to the Kotlin file here. I'm going to make a simple Kotlin exception, like so. So this is the bit where you inherit something from another or implement an interface in Kotlin. And we're going to fix the imports, add a throw catch here. Yes, add exception. So this is our very simple aggregate. Our command model is now done. This is it. This is what we're going to talk about. Well, we want to weigh in. I want to show you guys that this is actually running, right? So for that, I'm going to add a simple controller to our command model to actually call stuff on this guy. So I'm going to add a conference controller. I'm going to make this address controller, like so. I'm first going to do a hello world, because that's how you start off, right? But I'm going to make it a hello Kiev, because we're in Kiev. So hello Kiev. There we go. And we're going to add this under a get mapping. Hello. All right, now I need to put my conference application, run it. So this brings us to the point that we can hopefully start it up, if the demo guys are nice enough. Well, it started, so yay, that works. First bit is done. And let's see if the hello world bit is actually running. So let's go to localhost. Hello. Awesome, this is working, cool. So now we're going back to our conference controller, because we want to add a way to actually publish commands, because what's going to happen otherwise? So we're going to make this a void, because we don't care about the return type here. And I'm going to create conference, like so. I'm going to add this to the basic gap mapping, because I'm going to use it quite often. And this is the point where you want to use the command bus in Axon. But we also got a convenience function, the command gateway, which is a bit nicer to use. So that's what I'm going to introduce here by private final command gateway. Like so. Instantiate the constructor. Go to this guy. And here we got several send functions. We can do a send and wait, so blocking wait till the command has been finished. Or we can do a send with a command callback, or just a regular send. And we're going for the send right now. And on this point, we're going to create a conference, so publish this command. So for that, we need a conference ID. So, oh, that's very small. We need a conference ID and a conference name. And for IDs, I typically like to use random UUID to string conference ID. Gonna copy that, put it in here, and we're gonna create the JavaDay Kiev 2017. All right, and we want to add a couple of talks as well. So we add this, duplicate my cursor as well, do add talk command. And the first bit is the talk title, and the second bit is the speaker. So we first have somebody talking about how to do Kotlin. He actually doesn't know it either. This is going to be by Alice. I'm going to bit about clean coding. I think this is a Bob thing, so let's do that for Bob. And somebody is talking about the Axon Framework. It's probably me. All right. So let's start it up and see what happens. Cool, start it up. So we still got this guy working. Yes, that's nice. So let's go to the regular local host. So this is what I expected. I don't want any return values here, so this is empty. And let's go back to our application. And we've got warnings here. The add talk command, and we're missing something, the target aggregate identifier. So I did this on purpose to show you that this is quite important. So I'm going back to the conference API here. So we've got two commands, right? We've got one which instantiates the command model, and the other one which does something on that command model. And we reference that through the conference ID, but we haven't let Axon know that that is the thing which references this command to that aggregate. So we need to add this annotation there, and that's all we need in this sense. And I'm going to add a bit of logging to our command gateway so that you guys can see our commands going through. So I'm now going to use a callback system in Axon. I'm going to use a logging callback. So this is basically just going to do stuff on an OK or an exception and log that stuff has happened. So we can start this up again. Cool, that worked. And we go back to our system, still blank, as we expected it. We go back, and we see that command executed successfully, the create conference and the add talks. Success, great. Now I also want to show the decision-making bit in this guy, so I'm going back to our conference command controller, and I'm going to duplicate one of the talks. So let's take the stance that somebody else, let's call it my boss, is going to talk about the Axon Framework. Well, that doesn't make sense because I'm already giving the talk, so why is he doing that, right? So let's see what happens if we hit that endpoint with a duplicate talk, and we expect the duplicate talk exception, of course. All right. So we hit the endpoint again. And yeah, cool, we got an exception in here. And let's see what exception it is. Aha, the duplicate talk exception. So that worked out fine as well. So I've now showed you guys a simple command model, a way into that command model, but I haven't showed you guys that the events are actually going through our system. So I'm going to add an event logger for that. So I'm going to add a new class, going to get an event logger. And I've actually cheat sheeted this stuff because this is not too interesting to code. And I'm going to add that over here. And I can note a couple of things here. So first off, this is just the Spring add component annotation. And Axon in a Spring environment will automatically look for all the components with message handling functions. So it will look for all the command handling and event handling annotated functions in there. And another thing to note here is that I'm doing @EventHandler rather than @EventSourcingHandler. So typically in Axon, the event sourcing handlers are to source your command model, your aggregates, from your event store. Whilst query models, so this is a very simple query model to just log stuff, will just listen events as they happen. So it's not sourcing it always. You could make it so, but it's not doing that from default. And the last bit, which is interesting here, is that I'm looking for, so the first parameter in message handling functions is either the command or the event. But I'm looking here for object-object, which might seem a bit weird. But what Axon does, it will look for the most specific implementation of an event coming through. And as everything in Java is an object, this stuff works. So let's start it up again to just show you that the events are also going through our system. Got a lot of rebooting to do today. Cool. Going back, hitting this endpoint again, still nothing over here. We go back and success. We see the event logger, the events coming through and the commands coming through. Awesome. So this concludes our command model side of the application for now. We're going to add a query model to this. And the query model we're going to do is we want to see which conferences we have in our setup. So we're going to add a conference event handler class for this, which we're going to do component, like so. And we're going to listen for the conference created event. Conference created event, cool. And this is in the @event handler. But I haven't added the actual query model yet, right? I haven't added a projection to fill this on based on this event. So I'm going to add another Kotlin file for that because it's concise. Conference views, all right? And I'm going to make a simple entity, which I'm not going to bother you with because that's not Axon specific. So, all right, we got a very simple conference view, @entity and @ID. And there's two Kotlin things to note here. So by default, all the parameters in Kotlin are nullable. And you need to add the question mark to make it nullable. And I'm adding default values here in the constructor. And the added benefit of doing this in a data class means that Kotlin will create a no-arg constructor for you, something we need for entities. So again, very simple way to approach this, I think. So we also need a repository to store this in. So we're going to add a repository for that. Repository, yes. Always get that wrong. Cool. And we're going to make this a JPA repository because that's what we're using. Conference view string. All right. And this is the guy we're going to wire in our conference event handler over here. So private final, conference view, add a constructor, and we're going to do a save of a new conference view over here, like so. All right, so this works, but I also want to show you that you can query this stuff, otherwise it's not that valid to do this. So we're going to add another controller in our separate query model package, our separate neatly set up micro monolith here. Controller, conference view, and we're going to make this a REST controller as well. We're going to wire the private final conference view repository automatically, and we're going to add a get mapping, which I also set up so I don't have to write another get mapping in front of you guys. Fix the imports. This works, and for the keen eye in my application properties, I was dropping my database every time, and now I actually want to store that stuff, so I'm going to do an update. So starting up again, like so. Cool, start it up. I'm going back to Chrome. Cool, this still works. Okay, we hit the create conference endpoint, and we got our events here, so I think it worked. So let's go to localhost conferences, And success. We got a conference ID in here. So let's show you that if I do this a couple of times, that we've got several conferences in our repository. So yes, nice. So it's all the same, but for the sake of this demo, this is enough, I think. So we've got our awesome application. Our conference application has been running for some time, and people are loving it. But at a certain point, the business tells us that they want another view. They want to see all the speakers which have been talking on those conferences. So we add a speaker view and a speaker repository, and we listen to the talk edit event to do that stuff. So I'm going back to my project here, going to the conference event handler, and going to add another event handler there, not with inserts. Talk edit event, oops, like so, another event handler. Yeah, but we first need the query model, right? It doesn't make sense to do this without a query model. So I cheat sheeted this as well, because this might have been a waste of time, although I'm pretty good on time, actually. Oh, nice. So we have a very simple speaker view with the speaker as the ID in this sense, also an entity, and an element collection of mutable lists. So there's also specific to Kotlin, lists are by definition immutable collections, and as this is the view and we want to adjust that list of talks, we make it a mutable list. And we default it so that we get the noarg constructor from Kotlin out of the box for free. All right, so we go back and we have to introduce a repository for this guy as well. Speaker view repository, make this an interface. And do another JPA extends with speaker view string. That, cool. And we're going to wire this in our event in the conference event handler to be able to store stuff on this event happening. So private final speaker view repository. Get that out of the box. Let's get away of those guys. It's not interesting. And we, on that event happening, we want to first check whether this guy already exists. So we do speaker view.find1 event.get speaker. All right, speaker view. We're going to do a very, we're going to instantiate the list up front here. So we're going to make a list of string talks using that guy. We're first going to check whether the speaker view is null. So this is very, it works. It's not that nice, but this works for now. We'll make a new array list on this happening. And else, we know that we already have a speaker view in that sense. So in that case, we retrieve talks becomes speaker view.get talks. And once that has happened, we do a speaker view repository.save new speaker view. And we're going to do the event.get speaker. I'm going to make this a variable because we're using it in two places, speaker. And we're going to add the talks list. So that's it. That's what we're going to do here. Very simple. And we also want to be able to query this just like we want to be able to query our speaker, our conference views. So we go back to our conference view controller and add another get mapping for that. So I'm going to do another speaker view dot add path variable string speaker, like so. And we do this a get mapping slash speaker, like so. And we need to wire this guy as well, otherwise we're not doing stuff. Private or final, I still got that here, speaker view. Add that to the constructor. Ah, I've added another constructor rather than another get mapping. Cool. Adjust this. Okay, didn't catch. All right, now it did. We're going to return something from our speaker view repository. Find one speaker. All right. So we're able to run this. So let's do that. Right. The conference application has started up with our new view in place. So let's see what happens if we query that guy. So this is still alive. So we go to localhost speaker, and we're going to look for Bob. We don't got nothing, right? Which kind of makes sense, because we've got events in our event store, but we haven't told our new speaker view to be updated based on the stuff we have in our event store. So if I'm going back and I'm going to hit this endpoint to create another conference, we see we've got one talk for Bob in there. Oh, we don't have any talks, so I'm not adding it correctly. Let's copy that bit to make that work at least, so I can show you guys that it is working. So I already cheat sheeted this as well, but I figured let's wing it. But yeah, the demo guys were nice enough. So, all right, I don't really, I wasn't adding the talk to the list. That was the bit I was forgetting there. So I'm going to start it up again to show you guys the same thing. Now we should still have an empty list for Bob, because we don't have any talks for this guy. Cool. If we hit this endpoint again, Bob now has one talk. So, but what I was explaining, we have a ton of conferences for JavaDay in here, but Bob is speaking at all those conferences, talking about clean coding, but we only see one talk from Bob. So what we want to do here, so this is where another specific Axon thing comes into play. So by default, all the event handling components are handled by an event processor in Axon. And the default one is a subscribing one, so a push mechanism. So as an event happens, the event is sent to all the subscribing event processors and it's handled at that point. But we can also change that to a pull mechanism by introducing a tracking event processor. So a tracking event processor keeps track of where it was at handling the events from the event store. So what happens if we introduce a new tracking event processor as the basis for our conference view event handler? It will look in the token store because it stores its knowledge of where it was in a token, and it will see that there is no token for it. So it needs to start from the beginning of time. So that is how we're going to event source our speaker view based on stuff which has happened before. So I'm going to do that by adding a bit of configuration in the application class here. And I'm going to auto-wire this guy, a public void, and we're going to enable tracking. So by default, it's subscribing, but we're going to adjust that. And we're going to do that by wiring the event handling configuration. So this is a bit of the configuration Axon uses to internally do stuff based on a Spring Boot auto starter package. Event handling config. And we've got a very simple function for that. So this switches the default from subscribing to tracking. That's it. Now we are pulling our events on our event handling components rather than listening to stuff as they happen. So let's reboot our application here. Cool. And we already see something funny. We see that our event logger is handling all our events, again, all the stuff which is in the event store. And that is because our event logger is also an event handling component, so also was also behind the subscribing event processor, so doing stuff as it happened. And as we switch the default to tracking, the event logger also thinks, hey, I need to start from the beginning because I don't have a token. So it will handle all the events and push them to our event handler here, the object.object, and we'll call this function again. But the same should have come into place for our conference event handler over here. So our speaker views should now be filled. So as we started up the application, so this still works. We can still say hello to you guys, but now Bob has tons of stuff. Nice, exactly what we wanted. And same holds for me, and the same holds for Alice, which is going to talk about Kotlin but doesn't really know how. All right, so this concludes the demo I was going to give you guys. So let's go over it again for a bit. So I've been structuring the coding session in 3 main points, right? So the core API, the command model, and the query model. So for the core API, it was very simple. I was just adding a Kotlin file and adding the 2 commands and 2 events we wanted to happen in our system. So the create conference and the add talk and events and so on. And this, the first bit of Axon came into play here, the add target aggregate identifier, to signal Axon which field in the command is the identifying field to go to the right aggregate. So Axon will look for the add target aggregate identifier in its commands and the add aggregate identifier field in the aggregates and try to match that, and then it will find the right one. So then we go to our command model. This is where I showed a very simple aggregate, the conference aggregate, and use the add aggregate annotation. So automatically require the required building blocks for us from Axon. I added a command handler with some decision making on the add talk command that we didn't want to do duplicate talks. Our first event sourcing bit came into play here because we wanted to event source the conference ID and all the talks we had to make our decisions. That aggregate identifier on the conference ID to signal that that was the identifying field in the conference, and a simple controller with the convenience command gateway to actually publish commands in our setup. Second, or last actually, the query model. I showed you guys two event handling components, the event logger and the conference event handler, which are Spring Beans, so that Axon will automatically look for all the message handling, so add event handler functions in those. I showed you guys how to update query models on that, showed a simple controller with query model repository to grab them for you. And I discussed a bit the subscribing and the tracking event processes, so the pushing and the pulling bit. So this concludes my talk. For more information, you can go to the Axon Framework or Axonic guys. It's open source, so you guys can contribute to Axon Framework if you'd want to. And if you want to see the solution I've been coding here, you can go to the last bit up there. And if you want some more in-depth stuff to start off with Axon Framework, please come to me. And we still got plenty of time for questions, actually. So fire away. So there should be a microphone on the way now. And he's going to the, okay. Yeah. I've seen several questions there. Okay, that's fine. Yes, we could have added, so for the command model, so for the create conference command, we just, or the create conference endpoint, we did a create of the conference in several talks, right? But to source that conference, we only had to load those 4 events. So in this case, that's pretty simple. But like I explained, if you're sourcing based on several events or millions of events, you need to read all of those to rehydrate your aggregate in that sense. But that's where snapshotting comes into play, which is already in Axon, and you can plug that in, but I haven't been showing that bit. So the question was how to do snapshotting in this sense. So I believe up front are a couple of more questions. So we could do it shouting if the microphone isn't working. I'm fine with that, but Technics is looking what the issue is. That's a bummer. You could just go on. Yeah, sorry.
One of your examples, you were showing us this bus where you handle commands and where when you declare objects, well, methods that handle events.
Yes.
So check. Okay.
Awesome.
So the question is it on purpose there in one class? Because I mean the invocation of a method is faster than invocation of event listener and all this stuff. Or it's just for demonstration purposes, they're on the same class?
So I typically do this. So if we're setting up an Axon application with event sourcing in mind, which typically means you're going to event source your command model, I typically put them in one class. So I have all my command handlers up top, because that's the decision-making bit. And that's where I'm not going to do any state adjustments, none at all. And the event sourcing bit is where I'm going to do my state changes, and I'll push that to the bottom a bit. But I'm not sure whether that answers your question. So
actually, no, it's not. My question was specifically, if you handle all this stuff in one class and in one component, why wouldn't you just use methods, not invoke listeners? Okay, on command, on specific command, you dispatch one event, and this one event is handled by one event handler, right?
Yes.
So what's the point?
So this conference, the conference there with the event sourcing handlers, those handlers are only called for events which are published by its own aggregate. So it's not going to listen to any other events. Does that? I'm not sure whether I'm still answering your question though. So it's not that it's going to listen to everything. That part isn't going to listen to everything. It's only going to listen to its own events because it uses it to source itself based on that. Yes.
I wanted to explain just a bit the question. The commands may have some other side effects than just events, and the events should be saved. And my question is, how do we implement an event store in Axon?
So that's you get that out of the box. So because I was using the Spring Boot starter JPA, we automatically get a JPA event storage engine. And as we have an actual event database implementation, Postgres, it will know it needs to do an embedded event store. So that's all out of the box. And we can make some certain decisions in that place if we want to, but you don't have to write your own event store. That's already in there.
We have several implementations for that, yeah?
Yeah, there are a couple. You have got the simple event bus, event store, the embedded event store, the locking one. Yeah.
Okay, thank you.
So you could come to me afterwards, so maybe we can discuss it a bit better, okay? Cool.
What event bus can you have in Exxon?
Could you repeat?
What event bus can you have in Exxon? So what is a message queue? What do you use?
So in this application, I wasn't really using a message queue. So it's just sending events over and over. And you could use, so if you want to split up your application and have the command and the query side apart, you can add the Axon AIMQP module for you, and you can add another, so that will work through a Rabbit or Redis. So any implementation of AIMQP you could use to send your events over from one side or another.
Hello. Can you say a few words, please, about transactions with Exxon, with events, and can be done some kind of distributed transactions using Exxon?
Yes. So in the first example, when I was still doing a subscribing event processor, the bit where it's handling a command, what happens when it's applying that event, so publishing that event, is the first thing it will do is it's stored in the event store, and then it will go to all the subscribing event processors. That was all in one thread, so in one transaction. Once I introduced the tracking bit, the first transaction was just storing the event, looking for any listening parties, but there were none. So then it was that was done there, and then a separate thread was listening to that guy. If you could also distribute your command bus if you'd want to. We've got a distributed command bus implementation for that, which supports JGroups and Spring Cloud at this point, so you can choose which version of distributing command bus you want to use. So that's for the command side and event side. I had another thing in mind which I'm forgetting right now. Sorry, I'm blanking a bit. If you want more answers to this, you can. Yeah, I got it. So let's say we've got several command models in our system, and we want to do transactions between those two, right? So we've got an order and a shipment stuff. That's probably the thing you want to go to. So in Axon, you typically do that through the use of sagas, which give you the option to do a complex business transaction. So a complex business transaction, a saga will listen to events, so stuff is being happened, and it will handle the transaction in there and will check. It will publish commands typically based on those events happening. So you have a saga for a certain group of aggregates. So it does it handles the transaction between a group of aggregates or bounded contexts in that sense. Does that answer your question a bit? Cool. Thanks.
Hello, Chuck.
So yeah, there's one in the back. Sorry.
First of all, thank you for your talk. Your framework, sorry, looks awesome.
Thank you.
My question is related to interaction between different DDD contexts. Is it possible to leverage?
I'm sorry, I can't quite hear you. Could you?
Is it possible to leverage interaction between different DDD contexts? For example, if they run on different JVMs. For example, I would like to subscribe to conference created event, and once I get it, I would like to query your repository and get the conference details, for example. Is it possible to raise condition once I get the event and conference really created and put it to a repository?
Yeah, you've got eventual consistency in that side. No, that's true. So there are ways to order your event processors, but I typically suggest against that. So I think that an event processor or a group of event processors, because you can group several event handling components together in one processor, they should handle the events on their own. They shouldn't be reliant on any other data sources, typically, ideally. And you can do that because everybody can listen to all the events in your setup. So you should regard every event processor to be able to be part of its own application. So there were 2 questions up front here, but I see I'm out of time. So I'm not sure if we can do that. Otherwise, so there was here, and I believe someone there.
So where can you suggest you can use such a framework or a pattern CQRS? What's the best appliances for it?
Yeah, that's a tough one. So I've been using this on several iterations. So the first one was a roadside assistance. So if your car breaks down and you want to fix stuff, we had a very intricate command model which had to make a lot of decisions, and we want to separate that from our queries because we didn't want to tie those together, right? We wanted to be able to scale that up. So that was a bit where we really wanted to use that stuff because our command model, the decision-making bit was very important. I'm currently on a project to make the loan process in the United States to become easier. And when you're applying to a loan, so to buy a house, there are also a tremendous amount of rules you have to apply to. And you can put all those rules on the command modeling side of things, and you can just propagate if stuff has happened. So that's also typically a part where we want to pull it apart. Because in the loan sector, you also have tons and tons of projections you want to show, and the command model is really quite intricate, and you don't want to mix those two. So those are 2 examples. I've also seen it in betting and in gaming. I know there are a couple of airports which are using it. Quite some usages. So that's not really concrete, but no.
I have a question. If you restart application, your view will be rebuilt, right?
The command model will be rebuilt at the point when I'm asking to perform another command on it. So the command model, the aggregate, is not always in its state because we're event sourcing that. So as a new command for an aggregate comes in, the Axon will retrieve all the events for that aggregate, call all the event sourcing handlers to recreate that aggregate, and then it will publish that command on it.
I'm about views.
The views, yeah. So typically, so that's where I put the difference between event sourcing handler and the event handler. So our query views are typically just created at once. And if you want to adjust your query views, you typically drop those and you rebuild it. So you drop those, you put them behind the tracking event processor because that's the way to re-handle all the events to that processor, and that will automatically create the view for you. If you want that to be based on event sourcing, that will require you some components to create on your own.
And it's done only on startup, right?
Sorry?
Views rebuilds are done only on startup.
You could do that on startup, yes.
Can I do it lazily, for example, or by?
Yes, you can also do that lazily. I've done it at my first Axon project where so the roadside assistance thing, we were having cases for somebody having his car breaking down, and we didn't want to store all those views because at a certain time that case is not going to be called anymore because it's already 6 months old. So the chances of having to have that thing in storage wasn't that big. So we adjusted it to be an event sourcing repository, which we dropped our views at a certain point in time. But when we asked it, we know, oh, okay, we need to rebuild this guy. So we grab all the events for this case, and we rebuild it by calling the event handling component. But that's a custom thing you'd have to create yourself. That's not built into Axon. One more question.
Can we create snapshots with Exxon? And if so, then how? How can we set up it?
So on the command model, so typically the query side is just created, like I just explained. So you could do snapshotting there as well, but you have to implement it yourself. On the command model side of things, you just have to wire certain bits in the configuration to trigger you want to snapshot that aggregate. And you can do that on certain points in time. So you can do that under, if, for example, 10 events have happened, or on certain timestamps, or if loading takes a certain time, then you can save the aggregate, its state, and rehydrate that if you want to.
Okay, thank you.
Last question.
Can we query the current state of an aggregate?
So we are currently working on building a query bus and query handlers and all the required components to be able to do that. So that's coming somewhere this year or the start of next year, but we are going to surface that because it's a question we get a lot. So at this point, no, you have to create that yourself, but you could also wait a couple of months and you get it from us. So cool.